Hello friends, I am Professor Rahul Hunkalas, Assistant Professor and Workshop Superintendent from NB Navle Sinhagad College of Engineering, Solapur. I am having total teaching experience of 12 years and my specialization in Mechanical Design Engineering. Now, today we are going to discuss very important point in testing and performance of an IC engine, that is a heat balance sheet. Before this, in earlier videos, we have already discussed the different performance parameters, the different definitions along with their different formulas. Now, here we are going to understand the meaning of heat balance sheet, which is very important, and we have to solve the different numericals depend on this heat balance sheet. Here we are going to understand first what do you mean by a heat balance sheet. Heat balance sheet describes the performance of an engine. See, there is no any kind of engine which gives 100% efficiency. There is no any kind of engine. So, why this is not happen with the engine? We can understand with the help of heat balance sheet. It is one kind of a balance sheet. In economy, in financial, we know there is a account means how much amount we are supplying and how much amount we are getting. That is one kind of a finance sheet. Now similarly, there is a heat balance sheet in the thing of engine itself. Heat balance sheet describes the performance of an engine. It is a one kind of a sheet, an account of heat supplied and heat utilized in the various ways in the engine system. The necessary information concerning about the performance of an engine is obtained from the heat balance sheet. It is generally done on the second basis, on the minute basis, or on the hour basis. To draw the heat balance sheet for an IC engines, it runs on a constant load, and then we can get the indicator diagram. Now, the quantity of fuel used in a given time and its calorific value, the amount and the inlet and outlet temperature of cooling water, weight of the exhaust gases are being recorded during the test. After calculating of indicated power and brake power, the heat in different forms is found as follows. Now, to calculate the heat balance sheet, we have to make the calculation in the following way. The first one or the first formula to calculate heat supplied by the fuel. Now, for petrol and for oil engine, let us consider heat supplied is indicated with the help of letter capital Q, and its formula is mass of fuel into calorific value, that is MF into C. And if gas is there, or for gas engine, this formula is heat supplied, that is Q is equal to volume of a gas into calorific value, that is V into C. Now this is about heat supplied by fuel. Now under this heat supplied by fuel, the sub point first one, that is a heat absorbed in indicated power. Now we have the formula heat equivalent of indicated power per minute, that is equal to indicated power in 60 into 60, and its unit is kilojoule. The second one, heat taken away by cooling water, its formula is mass of water MW into CW, that is the specific weight of water, into T2 minus T1, where MW is equal to mass of cooling water used per minute, then T1 and T2 are the initial and final temperature of cooling water, and CW, that is specific heat of water, and its standard value is 4.18 kilojoule per kg degree Kelvin. The third point, that is heat taken away by the exhaust gases. Here we are using the Roman letters 1, 2 and 3. Heat taken away by exhaust gases is equal to M suffix E into C suffix PG into in bracket TE minus T suffix R bracket close, where M suffix C is equal to mass of exhaust gases in kg per minute, CPG is equal to mean specific heat at a constant pressure, T suffix E is equal to temperature of exhaust gases, T suffix R is equal to room temperature. Then the fourth one, that is heat unaccounted. Now With the help of this above calculation, finally we are going to calculate heat unaccounted, means this is one kind of a losses, and because of this only there is no any kind of engine will give 100% efficiency. Now we can calculate the heat unaccounted, that is equal to total heat supplied, that is Q suffix S minus the summation of first plus second plus third. Now as we have seen, the first one, that is heat absorbed in indicated power, the second one, that is the heat taken away by cooling water, and third one, that is the heat taken away by exhaust gases. By addition of this, here we have the summation of first plus second plus 3, and the addition of all these three, we have to minus this value from total heat supplied, that is Qs minus the summation of first plus second plus 3 third, and this way we can get the heat unaccounted. And finally we have to make the table like this, and this table is nothing but called as the heat balance sheet, where in the first column we have the item, in the second column we have the kilojoule, and the third one, that is a percentage. Now in this item column we have the first value, that is the heat supplied by fuel, that is total heat supplied by fuel Qs. Now we have to write that value in terms of kilojoule, and we have to write the percentage, that will become 100%. Now the first, second, third and fourth, as we have already discussed about this, first, second, third, fourth, we have to put that values over here, and we have to make the summation of all this, and we have to write in terms of total, then in terms of kilojoule and in terms of percentage. This is nothing but called as a heat balance sheet. We'll see in detail while solving the different numericals depend on this particular heat balance sheet, and this heat balance sheet is very important to find out the different losses in any kind of a engine. Thank you so much to watch this video.